Hi Lucas, I just forgot like 20 seconds. So we're graphing quadratics in vertex form and remembering how to change from standard to vertex. All right, so that's the most graphing friendly form right there, vertex form. And it's so graphing friendly because H and K represent the vertex. So that's the point that it starts at. And A tells you the step pattern. Okay, and the step pattern, we'll talk about that first. So graph the parabola y equals -2 x plus 4 squared plus 7. So based on this formula here, see if you can figure out what A is, what H is, and what K is. So you're basing it off this formula. What would the A be? What would the H be? What would the K be? Anyone think they know the A? Yeah. H?
-4.
Very good. Okay. All right. So how many people have positive 4 here instead of -4? Just one? 2. Okay. All right. So see how this formula has a negative in the formula? So the only way that this could be positive 4 is if it was x minus -4. You'd never see that written, but when you subtract a negative, you really add. Okay, so H is actually -4. So if you see a positive in the bracket, it's the opposite. If you see a negative in the bracket, you just take the number because the minus is built into the formula. Okay, once you know A, H, and K, H and K form the vertex. So the vertex of that parabola is at -4 and +7. Right there. Okay. Now the step number is -2. Okay. And the step number, if the step number is negative, it means you're going down from the vertex. If the step number is positive, it means you'd be going up from the vertex. Okay? And just the general value, if you look at what A does in general, which we'll look at up here, you're either going up or down, depending on whether it's positive or negative. 1 times A, 3 times A, 5 times A, etc. 7 times A. Okay? So if we apply that meaning of the step value, and our step number is -2, the negative means we're going down. 1 times A, well, A is 2. The negative means down, so ignore the negative now. We just know we're going downward. We're going downward 1 times 2, which is 2. 3 times 2, which is 6. 5 times 2, which is 10. Okay? So all we need to know is the vertex and the step number, and we can draw the parabola. Because it means from our vertex, we're going to go over 1, down 2 on both sides. And then over 1 and down 6 on both sides. And then over 1 and down 10 on both sides. And I can't quite fit that in. So then you're joining it with a smooth parabola-like curve here. And that's your parabola in vertex form. So we graphed the parabola. There's our example. And notice that the things about this parabola, remembering back to grade 10, this is called the vertex again. Okay. This specific parabola has a maximum value. Because it's turning downwards, this parabola never gets higher than 7. Okay, does everyone see that? Has a maximum value of 7. Okay, and the mirror line is called the axis of symmetry. So this mirror line here, where if you fold it in half along that mirror line, the two sides line up on each other, is called the axis of symmetry. And because it's a vertical line, the axis of symmetry has the equation that a vertical line would have. All vertical lines have the equation x equals whatever the x value is, the x coordinate of the vertex, so -4 would be your axis of symmetry. So I think I've kind of have a little grade 10 recap of graphing a parabola in vertex form. Okay. All right, so draw a graph of the parabola y equals x squared plus 6x plus 3 by changing it into vertex form. All right, so right now, this is called standard form. So another recap of grade 10. There are certain things that we know about something in standard form or a parabola in standard form. For instance, we know the a value because it's the same through all the forms. So a is going to be a positive 1, a number in front of x squared. Okay. And then this value, standard form looks like this. This value is the y-intercept, z. So we know if the a value is positive 1, we know it's going to be opening upwards because the a value is positive. So since it's got a positive up front, we know it's going to be like this. And we know the y-intercept is 3. So we know we should end up getting a point right there. But that's not enough to draw the graph. Okay, we want to put it into vertex form. And the process of putting it into vertex form is called completing the square. So, how many people remember how to complete the square? Oh, only my grade 10.
It's been a while.
A week? 2 weeks? 3 weeks? Okay, here we go. X squared plus 6x. Okay. So this is how you complete the square. So you take half that number, so half of 6 is 3, and square it. What's 3 squared? 9. So we add 9. And we subtract 9. Good. Why do we have to subtract 9 as well?
Because we just added 9.
Right. So you can't just add 9 without changing it. This is adding 0. All we did here was add 0. Can you add 0 without changing something? You can add 0 as many times as you want, and it still means the same thing, and we still have this plus 3. So you have to know in your heart that these two statements are equivalent. Okay? So y equals x squared plus 6x plus 3, and y equals x squared plus 6x plus 9 minus 9 plus 3 are exactly the same. Because all I did was add 0. Okay? Why did I do that? Why did I do that? Because then these first 3 terms are going to form a perfect square trinomial. Okay? And what's a perfect square trinomial? So if I saw this as a simple trinomial, and I didn't see it as a perfect square trinomial, I would know that it would factor to give me 2 factors that each start with an x, and then I need 2 numbers that multiply to 9 and add to 6. And those numbers are 3 and 3. Like I could try 1 and 9, and then 3 and 3. Okay? So, and another way of writing x plus 3 times x plus 3 is x plus 3 to the power of 2. Okay? Now, the process of taking half of 6 and squaring it ensures that this is always going to be a perfect square trinomial. Okay, it's always going to be one. So we put the number there that makes this a perfect square trinomial. Okay? So if I factor those first 3 that are in the box, I'm going to get x. So since I've created a perfect square trinomial, this is how you factor one. You mentally take the square root of this term, and it goes here, x. You take the sign from the middle term, and it goes here. You mentally take the square root of the last term, and it goes here, and then it's being squared. Okay? That takes care of the box. So I've just changed x squared plus 6x plus 9 into x plus 3 squared. Okay? But then the negative 9 and the positive 3 can be combined because they're both displaying numbers. Negative 9 plus 3 turns out to be negative 6. So now I put it in vertex form. So now I know that A is 1, okay, and never up front. And what are H and K? Yes.
And K is negative 6.
Good. So the vertex is going to be HK, so negative 3, negative 6. So now I can go on to my graph and plot the vertex at negative 3, negative 6. Okay? And then this step number being positive 1, because it's positive, it tells me that I'm going to be going up. And then it's up how much? So it's 1 times A, so 1 times 1, 3 times 1, which is 3, 5 times 1, which is 7, or sorry, 5, 7 times 1, which is 7, okay? So I use my step pattern from my vertex, and I go over 1 up 1 on both sides. And then from this point, I go over 1 and up 3 on both sides. And then from this point, I go over 1 and up 1, 2, 3, 4, 5 on both sides, and I find my y-intercept. And then I go over 1 up 1, 2, 3, 4, 5, 6, 7 on both sides. And then I've got all my points, and I just join them with a smooth curve. So draw a graph of the parabola by changing it. Okay, we did that then. Okay. There's my first example. All right, our next one. Rewrite each parabola in vertex form using the method of completing the square, which is what we just did. Sketch the graph of the parabola and state its vertex and its maximum or minimum value. Okay? All right, so our first one. So we start off y equals x squared minus 10x. And then I want to add something that makes the first 3 terms a perfect square trinomial. Good. So I take half of 10, which is 5, and square it. 5 squared is 25. So I add 25. And then I subtract 25, so really all I've done is add 0. And then I add my 18. Okay? Then first 3 terms, I created my own perfect square trinomial by taking half of 10 and squaring it, and adding it and subtracting it. So see if you can get the x part of the vertex. What would be in these brackets with the square roots? So you can remember how to figure out what goes in this. Curious, what do you think it is?
-5.
X minus 5? Okay, you're right. Okay, so remember, the square root of x squared goes here, the sign from the middle term goes here, and the square root of 25 goes here. Okay? That's how a perfect square trinomial factors. And then negative 25 plus 18 turns out to be negative 7. Okay? All right, so now you put it in vertex form, figure out what A, H, and K are. And then take out A, H, and K. There's?
A is 1.
Yep,
H is 5.
yep,
K is -7.
very good. Okay, any questions on how to get any of those three? Okay, so the vertex is HK, so it's going to be 5, negative 7. So we plot 5, negative 7 right here. And then the step number being positive 1, since it's positive, it means I'm going up. And then 1 times A is 1. 3 times A is 3, because A is 1. 5 times 1 is 5. And it'll be 7. Okay, so from my vertex, I go over 1, up 1. Over 1 from here, up 3 more. And then over 1 up 1, 2, 3, 4, 5 more. And then over 1 up 1, 2, 3, 4, 5, 6, 7 more. And you can always look, the y-intercept is a good check. The y-intercept should be 18. And you can see that if I was going to go over 1 and up 9 more, I would get to 18, or it's up there, so it makes sense that it would be positive 18. Okay, so there was more things they asked us to do with these questions. We have to rewrite it using vertex form by completing the square. We did it. Sketch the graph, state its vertex. We did maximum or minimum value. So this one has a lowest point, okay? A minimum value. And the minimum value is it never gets lower than negative 7. Which you can see in your equation, in your vertex form, it's your k value. It's the y coordinate of the vertex, okay? Great. Y equals negative 2x squared plus 8x minus 3. Okay, so remember for vertex form that it looks like this. The A is out front. And for us, the A value is negative 2. Does everyone see that? It's also in standard form. The A value is negative 2. And I need to get it out front of the X part of the vertex. Okay, and there's a way to do it. The first step when you're doing it is to factor the A value only. So the A value is negative 2 out of the terms that contain X. Okay? We call that partial factoring because we're not factoring it as a negative 3 because that just makes more work for us. Okay? So if I factor the negative 2 out of the terms containing X, what would I get inside the bracket? Yep. X squared. I'm not factoring negative 2x, but I'm just factoring negative 2x, okay? X squared minus 4x. So then close your bracket, minus 3. There's the first step, okay? And again, remember these things are equivalent. If I were to expand that negative 2 into this little bracket, I get it back exactly what I started with. Okay? That's the first step. Second step is to complete the square inside the bracket. So to complete the square inside the bracket, I take half of 4, which is 2, and I square it. 2 squared is 4. Everybody good there? So I add 4 to complete the square. That's how I complete the square. But then, so I'm only adding 0, I subtract 4. Close my bracket, and then I still have the minus 3 that's not in the bracket. Okay? Now, the first 3 terms in the bracket are my perfect square trinomial. So notice that right now I've got negative 2 multiplying everything in this whole entire bracket. Okay, that's what the negative 2 up front means. It's multiplying this whole entire bracket, but it's not multiplying the negative 3. Does everyone see that? It's multiplying this whole entire bracket here, everything that's inside of it. Okay? So if I factor this part, the perfect square trinomial, what would the perfect square trinomial be, the box? If I factor the box, what would it end up being? Close? Sign from the middle. X minus 2 squared. So the square root of x squared is x. The sign from the middle term is negative. The square root of 4 is 2. Okay? So I've still got the negative 2 multiplying all these 3 terms, because all I did was change these 3 terms into this bracket. Okay? Those are the same. But what do I do with the negative 4? It's not inside this bracket anymore. Yeah. Add it to the negative 3, that'd be nice, but it's being multiplied by the negative 2. You multiply to get it out of the brackets, to get it out of these brackets, or to expand something out of a bracket, you need to multiply it by what's out front of the bracket. Okay? So to free it from the brackets, to get it out of the brackets, I have to do negative 2 times negative 4, which gives me positive 8. Okay? That gets it out of the bracket, so it's no longer being multiplied by the negative 2. I've multiplied it by the negative 2. But then I still have the minus 3. Okay, so my final version is going to be y equals negative 2 times x minus 2 squared plus 5. And then from there, you're going to figure out what a, h, and k are. All right, so who thinks they know what A, H, and K are? Yep.
A is negative 2.
Yep.
H is 2.
Yep.
K is 5.
Everybody good? A, H, and K? So that means our vertex is at 2 and 5. Okay? Because our vertex is HK. So let's mark that on our graph, 2, 5. And then our step number is negative 2. The negative means down. And then for the 2, it's 1 times 2, which is 2. 3 times 2, which is 6. 5 times 2, which is 10. So from the vertex, I'm going to go down 2, down 6, and down 10. Okay, so from the vertex, over 1 down 2, over 1 down 6, and over 1 down 10 doesn't fit on. I hit the y-axis though, so my y-intercept should be -3. Was my y-intercept -3? Yes. Okay, so that's a good clue that I did it right. Remember, this number in standard form represents the y-intercept. So then drawing your parabola. And this one has a highest point or a maximum value. So it has a maximum value of 5. And again, that 5 is the y-coordinate of the vertex, the k value, okay? All right, the next one. All right, I'm going to give you time to try it. Okay. First step is to factor the -2 out of the first 2 terms. Okay, so I'll show you what the answer is, and then I'll kind of talk about what I've noticed over the years are the biggest mistakes people make. So that should be what you got. How many people got that for the first step? Great. Okay, so one of the pitfalls is forgetting to divide the 12 by -2, so you get +6x there. It's a really common error. And then dropping the x from there is another really common error. Okay, so that you have x squared minus 6 instead of x squared minus 6x. Those are the 2 most common ones. Okay, I think it's because you just have factoring in your head, so you want to common factor the x, but because all you do is you want step number out front, the a, and not the x, that's probably what's causing the issue. Okay, so you consciously think just factoring out the -2 because it's a step number. All right, so then the second step is to complete the square. So you write out the x squared minus 6x, then you have to take what's half of 6? 3. 3 squared, 3 times 3 is 9. So you add 9. But so that you can't just add 9, you have to subtract 9 too, so that all you really added is 0. Then you close your bracket, and then the -11 goes next. Okay, because it's not being multiplied by the -2. So that should be your next line. Then these 3 terms are your perfect square trinomial. Always takes 3 terms to make a trinomial. It's going right beside the -2, so still being multiplied by the -2. So I can factor it, and the way you factor it is the square root of x squared is x, the sign from the middle term is negative, the square root of 9 is 3, squared, that's what makes it a parabola. But then I can't get away from the fact that the -2 and the -9 are multiplying each other. So the only way to deal with that, so that they're no longer multiplying each other, is to do the multiplication. -2 times -9 gives you positive 18. So now it's free from the -2. And then you're -11. So that should be your next step. Okay? Putting brackets in the wrong space, that's another thing people sometimes get mixed up on. And then if you can make it to here, then you're golden. So plus 18 minus 11 is plus 7. So now you figure out your AHGK, which leads to your vertex and step number, and you can draw the parabola. So your vertex is going to be 3, 7. Right there. And then your step number being -2 means you're going to go down 1 times 2, which is 2, 3 times 2, which is 6, 5 times 2, which is 10. Okay? So from your vertex, you're going to go over 1, down 2 on both sides, over 1, down 6 on both sides, and over 1, down 10, which doesn't quite fit on both sides. You can always use your y-intercept to see if it makes sense. -11, yep, does. Just off the grid. And this one has a maximum value. So highest point of 7, which we see as our K value. Any questions? Coming back? Remembering it a little bit? Yeah. Okay. Okay, so how can you tell the maximum or minimum value of a parabola? So look back at the ones that we talked about having a maximum or minimum. How can you tell what, first of all, whether it's going to have a maximum or a minimum and what the value is going to be? Yep.
If the x is negative, or not the x, if the a is negative, it goes down.
Yes.
And the a is positive, it goes up.
Perfect. So A is positive means it looks like this, and A is negative means it looks like this. So if it opens up, says right, it has a minimum, and the minimum value or the maximum value is always the K. In this case, it would have a maximum of K. Good. Okay, so if A is positive, you know you're going to have a minimum value of K. And if A is negative, you know you're going to have a maximum value of K. All right, so you don't need the graph to pick out whether it has a maximum or minimum and what the value is. You can just use this rule here, okay? So that's what we're going to do next. Determine the vertex and the maximum or minimum value of each quadratic function. All right, so I'm going to give you thinking time here. All right, so everyone was factoring 3 out on the first step. And got x squared minus 4x for the most part as I walked around. So that should have been everybody's first step. Okay. Second step, complete the square inside the bracket. So to do that, I take half of 4, which is 2, and square it. But then I also have to subtract 4 so that I've really just added 0. And then I'm going to factor the perfect square trinomial, which is in the box. So square root of x squared is x, sine from the middle term, square root of 4 is 2, squared, that's what makes it a parabola. Then most people remembered that the negative 4 had to be multiplied by the 3 to get out of the bracket. So they had negative 12 here, which made me very happy, plus 9. And then they ended up getting y equals 3, x minus 2 squared minus 3. Okay? So you successfully started with standard form and ended up with vertex form. Okay? So my a is 3, my h is 2, and my k is negative 3, which means my vertex hk is going to be 2, negative 3. Because it wants the vertex. Now, does it have a maximum or a minimum? And how do you know? Minimum, because A is positive. And what is the minimum value? Anyone? Yep. Negative 3. It's the K. Okay? The K value. The is the maximum value or the minimum value, depending on. Okay? All right, great. All right, try then, how we'll do the next one together. All right, so first step is to factor the -2 out. So you guys should be able to do the first step, no problem. Okay, so if you factor the -2 out of the first two terms, you should get x squared minus, okay, one of the issues is getting the minus there, 7x. How many people got that first step? Excellent, okay. Okay, what makes this one harder?
You have to half the thing.
You have to have 7 and it's not an even number. So what's half of 7? 3.5. Okay, so then you have to square 3.5. 12.25. So in our next lesson today, we're going to be doing everything with fractions. Okay, but in this one, we're just warming up, so I chose one that had a perfect decimal that we could leave. Still the same procedure, just not as nice a number. Okay? So then to get what goes in the brackets, we still do the same thing. Square root of x squared is x. Sign from the middle term is minus. Square root of 12.25 is 3.5. Okay? Squared. And then you have to remember to get the negative 12.25 out of the bracket, and has to multiply by the -2. So that's going to give you positive 24.5. Oops, should have done that in red. And then minus 35. Negative 10.5?
Yeah.
Thank you. So A is -2, H is 3.5, and K is negative 10.5. So my vertex is 3.5, negative 10.5, HK. And then does this one have a maximum or a minimum? So maximum, because A is negative, means it would be going downward. So it has a maximum value. And the value is always the K value. So the maximum is negative 10.5. Okay. Great, word problem. A golfer hits a ball off of a dock into the lake. Okay, a function that models the height of the ball in feet above the water t seconds after being hit is h at t equals negative 5t squared plus 40t plus 3. What is the maximum height the ball reaches? So as soon as we're talking about a quadratic function, something squared, and we're talking about maximum, your brain should be telling you vertex form. Okay? The question doesn't tell you to put it in vertex form, Thank you. But as soon as you see that a question asks for a max or a min, you have to put it in vertex form to tell what the maximum or minimum is. Okay. So that's a clue in the question that tells you you need to put it in vertex form. And then also make a labeled sketch, and that's also going to be really important. We're going to do that with all our work problems, okay, to help make sense of what the vertex actually means when it's not just X and Y. In this case, it's H at T and T. So if I'm making a little sketch here off to the side, how do I know what goes on the Y-axis and how do I know what goes on the X-axis? Vertical and horizontal. How would I know what to label this? I'm not going to label it Y, because there's no Y over here. What am I going to label it? T, nope. T is where X would normally be. So this is going to be T.
Okay.
H, good. So height. Okay, and then look for clues in the question. Height is in feet. And time is in seconds. And we know this is always the y-intercept. So we know our graph's going to start at 3 on the vertical axis, okay? And it says it has a maximum height. We know the step number is negative, so we know it's an upside down parabola. So it's going to go something like this. Okay, and then see if it makes sense with the question. The golfer hits a ball off a dock into the lake. So the dock is obviously 3 feet above the lake, goes up into the air, and then it lands in the lake. What is the maximum height the ball reaches? Make a label sketch. Okay? So in order to figure out the maximum height, I have to put this into vertex form. So that's your next step, is to try to put that into vertex form. All right, so saw lots of people factoring the -5 out, which is great. So it would be t squared minus 8t bracket plus 3. So check and see if that was your first step. Okay, good. So then your second step is to complete the square inside the bracket. So you're going to take half of 8, which is 4, and square it. So let's add 16, subtract 16, close your bracket, plus 3. And then these 3 terms form your perfect square trinomial. So I can factor them. So that's going to give me square root of t squared is t, sign from the middle term is negative, square root of 16 is 4 squared. Okay, t minus 4 squared. And then I have to get the -16 out of the bracket by the distributive property, multiplying it by the -5, and that gives me positive 80. And then I still have the plus 3. So then I can figure out my vertex from there. My A is -5, my H is 4, and my K is 83, which means my vertex is 4 and 83. So I don't have like a grid here. But what I do know is that this represents the horizontal and this represents the vertical. Is everybody good with that? Okay, so this point here would be 4 if I read down from my graph, and 83 if I read across. Okay, so I have a horizontal coordinate of 4 and a vertical component of 83. Does that make sense? So then the question says, what is the maximum height the ball reaches? So it would be 83 feet. So therefore the ball reaches a max height of 83 feet. Okay. When does it reach its maximum height? Serious? 4 seconds. Okay, so I know that at 83 feet, it took 4 seconds to get there. That's the horizontal component of the vertex. Time is horizontal. Okay? So when does it reach its maximum height? 4 seconds after being hit. Okay, how long is the ball in the air? So if you look at the graph, I hit the ball, and then it goes up, and then it goes down. It wants to know how much time has passed between hitting it off the dock and it landing in the water. It wants to know how much time that is. Yep. That would be if it started at 0. You see what I'm saying? If I hit it right from the water, then it would be 8 seconds. So it's going to be around 8 seconds, but I hit it from the dock. So the dock's a bit above the water, 3 feet above the water, so it's going to be a little less than 8 seconds. Okay? But there should be a way that I can calculate that. And there is. So what you need to know is that the clue in the question is that when the ball hits the water, its height above the water is 0. Does everyone see that? When it hits the water, its height above the water is 0. Okay, so that's the clue that's hidden in the question. So it wants to know what's the time when the height is 0. So this, what's the time when h at t is equal to 0 when the height is 0. Okay? So, the easiest way to do this is to use vertex form, and the reason is because in vertex form, the t is only in one location. And if it's only in one spot, you can use reverse bedmass. So see, if you look at the standard form, there's a t squared and a t. But if you look in vertex form, the t is only in one spot right there. So it's easier to get by itself. Up here, how do you get t by itself when there's a t squared and a t? Okay? So we can replace h at t with 0. And then we want to use our amazing solving equation skills using reverse bedmass to slowly get t by itself. So here's t. I want to slowly get it by itself. What would I do to both sides first, do you think? Jack? Is exactly what you would do first. Good. So reverse bedmass, undo any adding or subtracting. So 0 subtract 83 is negative 83. thing you would do to both. Yeah. Yes, divide by -5. And then go to your calculator and see whether that's a nice number or not, meaning a decimal that just ends, or a integer. If not, just leave it as -83 over 5, or 83 over 5. It's 16.6 though, so that's fine. All right, still trying to get t by itself. So I'm taking care of the multiplying and dividing. How do I take care of the exponent of 2?
For
Square root both sides. With a caveat, all right, because this is a quadratic equation, t squared, quadratic equations have normally 2 solutions, okay? So on the number side where you have 16.6 square root of, there's a positive and negative square root, okay? And you just write it like that. And I'll just go through y again on a separate piece of paper, so just watch for now. So when you guys see the square root of 9, everybody automatically thinks 3, right? You only ever think of the positive square root. That's your brain's just trained to do that. But the square root of 9 is also -3. Why is the square root of 9 also -3? -3 times itself also gives you +9. Okay? So the square root of 9 is actually positive or -3. Okay? And normally we just care about the positive square root, but when we're in quadratics, we care about both, because depending on what the other signs in the question are, it may be the positive one that gets you the answer, it may be the negative one that gets you the answer, or it may be both. And we'll find that out later today and 2 Mondays from now as well. So for now, I'm just going to keep this as positive or negative. The square root of 16.6 equals t minus 4. Okay? Now, because this is an equation, the 2 sides are equal, I'd rather have the t on the left side, so I'm just going to switch the equation. So I'm going to switch the left and right side. For the equation, doesn't matter. Okay? What will be the last step to getting t by itself? Adding 4 to both sides? Okay. So I'm adding 4 to this, but I want to put the 4 first. So I want to make it look as 4 plus or minus the square root of 16.6, okay? So put the integer first, and this square root sign is actually called a radical sign, put the radical second. So the integer first, whether it's positive or negative, and then the radical or the square root part second. Now this is actually 2 solutions, so it breaks down into 2 solutions. 4 plus the square root of 16.6, and 4t equals 4 minus the square root of 16.6. Okay? And then we figure those out. So we go to our calculator now. We type in 4 plus 8.1 seconds. And 4 minus the square root of 16.6 gives me negative 0.07 seconds. And we consider this solution to be inadmissible because negative time doesn't make sense in this question. Okay? Having a negative time doesn't make sense in the question. So now that we know the answer, therefore, the ball hits the water after 8.1 seconds. Okay? So there's a lot of steps there in order to get t by itself. We'll do more of these in our next lesson. So our next lesson today is just this exact same stuff, only there would be fractions involved. Okay? So everyone's favorite